Good evening, sir.
Yeah, hi Nachiket. Yeah, let's go over. You can share the screen and can discuss. First, let's go through the requirement and then we will go through the solution.
Okay, sir. Okay, sir. So now my main objective or the problem statement is to automate the continuous that is pipeline orchestration, building the orchestration for seamless deployment and accessing the application. So for that, basically we need source code, which is like it should be stored in GitHub for further access. So thereon, the process will be going to happen through the pipeline that is using the Jenkins master. So in Jenkins, we going to build or we going to write the script as pulling the code from the GitHub and same thing to be built. So based on what language the code is about. So here we have gone through the Spring Boot, that is the Java-based application. So to build the Java-based application, especially the Spring Boot application, we'll be going with Maven package. So thereon, once the build has been successful, so that needs to be copied into the Docker file for developing the Docker image. So once the Docker image has been successfully created, and it should be pulled to the Docker Hub for further usage as well as versioning also. And later the same image will be pulled to the local or the server engine. So in implementation, I have gone with EC2 instance. Instead that I have installed the Docker and thereon I have run the microservice and I could able to access the same through the Postman API. So that was the main objective of my project or the problem statement. And so as I just mentioned, we need to have the GitHub repository to store our code or the source code, and that should be having the pom.xml, that is XML, where the project object model will be stored here. So whatever the content we do have or the dependencies to build the Maven-based application. So everything, all the dependencies are written in pom.xml file. So when we are integrating the GitHub with Jenkins pipeline, so the main the Jenkins will go and look into the pom.xml file for what needs to be done. So for that purpose, the pom.xml file is very much important while we are going with Spring Boot. And we'll be configuring the Jenkins, that is necessary plugins is Maven, because we are running with Maven based application or the Spring Boot. So we will be including the Maven integration and Docker pipeline. So the Docker is installed on the Jenkins server and Docker daemonic. So that is background in the server where the Jenkins is installed. The Docker will be doing with super privileges for doing the manipulation. Next thing, we need to run the Docker Hub account. So because whatever the image we going to create post build, so that needs to be stored in the Docker Hub as an packaged application, Docker packaged application of the image you can create. So an active Docker Hub account is required to store the Docker image. So and thereon, so to access the Docker Hub, we need to create the flag, that is the personal access token, to access the Docker. So same thing will be stored in the secure or the managed credential of global Jenkins. And thereon we need to have the AWS configuration, that is the AWS account we should be having, and with the proper IAM role. So we can go with the root also, but still in main or in production thing, it is advisable to go with the IAM permission, so that it will be having the very much limited access where we going to work, and which are the services we going to access. Only to those services we can able to have the access. So for that, it is advisable to go with IAM thing. And there on AWS CLI will be having the more, that is, if you only script, we'll be having the better work, and we can control everything from the command line itself. And accessing permission. Along with that, we need to have the RDS for storing the thing. That is storing the database related things. So we need to create the RDS MySQL thing, and that needs to be linked with my microservice before it going to be. When it comes to security aspects, so we cannot expose anything like information, sensitive information. It could be of main problem statement of the application, as well as the passwords and the user's name, like for the database and everything. So for that, we need to store all these things in the sensitive credential. That is where the credential management will come into this. So to pull from the GitHub, since we will be going with the private repository, we need to have the access to the GitHub account. So that needs to be, to access the GitHub private repo, we need to have the credentials of that GitHub account. So if you are going with full access of GitHub account by providing the root password, so that is not very suitable. So here we will be creating the PAT account with limited access. So where we will be having the option to only to read the thing from the GitHub, and same thing for the Docker and the AWS. So it's while we created the IAM role, so IAM user, so we will be getting the access as well as publicly to access the AWS account. So this is the IAM, and the permissions to be provided, that is the IAM roles, because each service needs to be interact with one another. Like if my EC2 instance wants to interact with either RDS things, so we need to grant the permission to, we need to update the IAM role. Only on that case, the EC2 will be having the access to, or to speak with RDS, unless until they cannot able to communicate each other, even though they are within the same ecosystem. So we need to provide the additional permissions, that is IAM roles. And when it comes to networking part, so all the things are deployed in an private VPC, and will be making accessible through the network API gateway. And container service. So the container service will be completely comes into existing Dockerization. So that is, so while we will be going with building the Docker image, containerized Docker image, so this is the root operating system like thing. So that this is the image. Based on this image, whatever the application is. If we are build the image on Python, means we need to pull the Docker image should be built in the Python base. So since we will be here going with Spring Boot migration, so we will be going with OpenJDK, that is the Java based things, and the Slim is the networking or the security thing to reduce any unavailable, that is a vulnerability or the bugs be fix. So it will be previously scanned. So once if any bugs are not found in this file, that is the image file, so it will be going to create the image and it will be pushed to the Docker. So regular scan Docker image for vulnerability before pushing to Docker. So by integrating this added security will be provided to the Docker image. And the database security. So here also will be deploying, that is we going to create the RDS, MySQL RDS inside the VPC itself. So there we will be having only grant to the communication to the only EC2 instance. Rather than that, no one can able to access since it is deployed under one VPC, and it will be abstracted to the computers. Since whatever the access ID of the endpoint will not be visible to the end users. And to monitor our application performance and all, we will be configuring the AWS CloudWatch, where we can able to get the logs of each transactions or the each movement of the applications. Each click will be recorded here, so everything can be fetched for further analyzation if we got if we encounter any errors during the performance. And here is the architecture. That is, initially the developer will commit the code to the GitHub repository. So once any new changes are committed to the GitHub repository, we will be setting up the webhook integration. So where webhook will be pushing or will be notifying the Jenkins saying that there is new changes have been happened in the repository. So kindly go with go and run the job. That is, go and build the application like that. It will be found to the Jenkins, and the Jenkins is deployed into the EC2 instance, and the build process will be automatically taken. So to run this build, to generate the build input application, so we will be writing this script. So that script will be followed. So initially,
Hey, Nachiket,
yes sir.
are you recording this session?
No sir.
Can you start recording also?
Yeah, okay sir. So the architectural diagram for complete automation from pulling the code from the GitHub and it is deploying into the server. So this is my architectural diagram. So whenever the developer go and commits the changes or commit the code into the GitHub repository, so the GitHub will going to modify the Jenkins pipeline saying that there is a new changes have been committed in the repository. Kindly go with building the new job like that. So once the web notifies the Jenkins, so automatically the Jenkins follows this script tag, which is the pipeline script, which is given as an instruction to the Jenkins to go with the procedure. So that is, we will have the multiple stages. So this statement will go into, that is, it will pull the code, that is the updated code or the new code which we have been committed by the developer. So it will be pulled by the Jenkins and it will be authenticated, saying that we will initially have been provided the credential. So since we will be going with the private repository, we need to provide the PAT, that is the personal access token, to access the GitHub repository from the Jenkins. So the authentication will be done. Post authentication, code will be pulled, and the next procedure is since we will be going with building the Spring Boot application, that is the Java base. So we will be going with an Maven package, that is the Maven dependencies, to build my application, that is MVN clean cover, the second stage. So once the build have been successfully completed, the artifact is nothing but the output from the Jenkins post successful running. We will be calling it as artifacts. So where our output will be stored. So that it will revert in the target thing. So from target, it will going to put the details of the successful build file. So whatever the name we have provided. So from that, it will going to build the Docker image. So to build the Docker image, initially we have also provided the Docker file in the GitHub repository itself. So it will go and refer to the GitHub repository file and it will be going to build the Docker image. That is the third step. So once the Docker image has been built successfully, the fourth step will be, it is going to push to the Docker hub. So before pushing to the Docker hub, the authentication will be happening here. So during the authentication, in the sense, to access the Docker hub account, so we need to initially tag my account to that Docker file. Fine. So post that the authentication will be happen. Same, the credentials should be provided, username as well as the path should be provided of the Docker account, and that needs to be authenticated. Post authentication, so the Docker image will be pushed to the Docker hub. So once the Docker hub having the image in the Docker, so that can be used for further usage, or we can share that image to with other persons to in the team itself. So who is maintaining the server of our deployment process. So that can be happening. And once the image have been pushed and it is stored in the Docker hub, so for deployment purpose, we can just pull that image by passing the command, that is Docker pull followed by the name of the, that is the username of the Docker hub followed by the name of the image and the tag. So that is the command to pull the Docker containerized application image to the server. That is, here we will be going to deploy the Docker image inside the EC2 instance. Fine. Suppose that once the deployment have been happened, we will going to run that container. So using the command. So once the container is, that is the container running the application inside. So the application will going to run inside the Docker container. So post the running the container without any logs or the errors. So we can able to access through the API call. So we can send the request. So the request will be from the API and then to the server. So if you are doing with anything related to the database thing, so it will be fetch from the, that is, it is going to provoke the call to the RDS. That is, it will make an API request to the RDS or the storage thing. So that details will be provided priorly. So where should it is going to fetch the details from the database and all. So it will going to fetch and it will revert it back to the server and it will respond through the API call itself to the end user. So next is archival plan. So next is archival plan, that is source code and build artifacts. So maintaining the source code in version controlled GitHub repository. So it is very much important.
It's called as archival plan.
Okay, sir. So sorry. So the archival plan will be going. So we will be implementing the archival plan in our project because we need to maintain the versions of the either the code or the Docker image. We need to maintain, and also the build or the artifacts. And so because it is very much important in future days. Some for an example, if my application is running well and good, so suddenly my application goes down or some features were not working as per our needs, so we need to roll back to the previous version itself. In those cases, we need to have the previous versions of source code or the jar file or the artifacts or the Docker image. So there it will come to and feature why we should have the archival plan. So for that, we need to maintain both the source code as well as the build artifacts. So next is Docker image I just mentioned, right? So we need to retain the older versions of the Docker images for the future usage in case of rollback purpose and all the thing. So though we can able to delete the Docker images in our server, but we should be able to retain the older images in the Docker hub by maintaining the versions, different versions. So periodical cleaning up of unused images to stay, that is the saving the storage in our server but not in the Docker hub. So in Docker hub, if we are going with more than 5 versions of application, so the previous 1 and 2 version is not much required since the version 5 is going well and good. In those cases, we can eradicate or we can delete or we can clean up the Docker image in Docker hub. And yet another one thing, it's not necessary to keep the version 1, 2, 3, 4 images in the server. So that could lead to having the more occupying the more storage space in our server, as well as it will going to that is the reliability as well as efficiency of the server will be obviously will be going down. So to do those things, so the current version which is running, so that image is much needed to retain in the server. So the previous versions, it's not required to have it in our active server, and the database also. So assume that anyway we have stored lakhs of users credential things, that is username as well as password and their credential to access the application. So suddenly one database or the database infrastructure got crashed out due to some disaster thing. So on that case, we need to keep the it's better to having the backup thing, that is the snapshot thing, so that whatever the configuration as well as the data we have stored in that database, that is the MySQL RDS, so the same data can be restored in a fraction of hours, so we can make it available to the end users also. So if you haven't kept the backup or the snapshot of that complete database thing, so the data completely will be lost, and there will be huge loss for the organization and even to the end users also, even those cannot able to access the application. So if you want to provide a good and reliable service to the end users, so each and everything needs to be backed up for any kind of rollback or any kind of disaster, to overcome the disaster destroys of our infrastructure. So for all those things, we need to better to have the backup for all our source code, database, everything. So, and also it's better to have the logs also. Sometimes so we cannot expect what error we going to encounter in which version, in which area of the service will be getting the error logs. So for analyzing the log, we need to store or we need to keep backup of the logs. And in future days, someone might comes and says like, my transaction was declined, but the amount got detected. So for all those things, we need to go and track the logs of the application, so where it is got stuck and why it is got stuck and what was the reason. So to monitor all those things, we need to have the logs of the individual life cycle of the transactions. And next is scalability. That is, it is very much important. So all the time we cannot go with the high-end infrastructure. So we will be going with the initial, the minimal requirement to run my application. We'll be going with that base infrastructure configuration thing. It could be of a server, storage thing, RAM, and the processing number of CPU, everything. So gradually, based on the incoming traffic, so my application should be capable, that is, my infrastructure should be capable of increasing the infrastructure by on itself by analyzing the incoming traffic or the memory utilization of the CPU. So for all those things, we should have already priorly configured the, that is scalability of each services. It could be of RDS, EC2, and all things. So it's very much important to have the auto scaling thing in each and every applications. That is the configure ECS service to scale based on the memory utilization and define minimum and maximum task limit to handle the traffic spikes. So why they have mentioned like minimum and maximum task limit to handle traffic spikes? So when there is a huge traffics are approaching, either it could be of some cyber attack or it could be of the normal traffic. So we cannot expect. So to provide more security to our application, so we need to mention the minimum as well as maximum task limit to handle the traffic spikes. So they might going to attack through the brute force attack by providing the multiple attacks. So on that case, the machine could not able to manage the things. So for that purpose, we will be going to set the maximum request limit to so and so that whatever the request is coming, so it will normally going to serve the purpose by going with that. And so when there is a huge traffic coming, so it will be diverted to the multiple servers. So the auto scaling will going to happen. So simultaneously the 3 or more containers will be going to run, started to run. So the traffic will be diverted to all the containers which are running, and so that they can able to serve the purpose, so without any latency things. And database scaling also. So today I might having 10 TB of client data, and tomorrow it could be of 100 TB of data. So all the time I cannot go and manually increase the data things. So based on the workload or the data things coming from the client, so it will going to monitor, and by itself it is going to scale up the database storage also, as well as the instance things for processing the data. That is RDS auto scaling thing. So why it is required to have API gateway throttling thing? So when there is a huge request or the API calls have been happening, so there would be some limit for handling the API request call, so from the client to the microservice. So in all the time it cannot go with the normal line, so it requires to go with high performance. On that case the throttling will come into exist. And the load balancer is very much important, as I mentioned, right? So there will be multiple containers will be created, and that traffic needs to be diverted to all the containers which are running. So for that we need to set up the load balancer on top of all the containers. Okay, so the load balancer will handle all the traffic. So it will think of like we're going to divert a few traffic, or the 10 traffic to container 1, 10 traffic to container 2, 10 traffic to container 3, like that. So it will going to handle the traffic also and distribute the workload to all the available server, and it won't go and pressurize the single server to get response. So there we can see the load balancer and the rollback plan. So in case of the version 2 or 3 having the lack of feature, or some features might not responding properly, on that case the features which are very much essential for that application, so to the client who are using those. So since the main objective of using that application is the main feature, so when main feature does not working properly, so immediately we need to take action. So we cannot go and again need to code, or we cannot go and undo the source code, and we need to again deploy all the process. So it will going to consume a lot of time. So for that time so we will again revert back to the archival plan. From there anyhow we will be having the backups of all events from the source code, artifacts, and that is the Docker container image, everything we will be having. So immediately we will roll back the version 3 to version 4. So we will release, and we will ask them to update the application again, and they can keep going with the previous service only. So meanwhile the team will again go and look into the version 3, what exactly the issue is happening, by looking into the logs. So for that we required the log is very much. So the automatic rollback process in Jenkins by maintaining the record of successful deployment. So in another case the deployment that is the build got successful, but the deployment haven't happened. So in that case we cannot go and expecting the version 3 of application. So since the deployment got terminated due to some reason in the middle of the script only, or in the middle of the pipeline, so on that case whatever the process have been happened till the 50% or 60% out of 100, so that will be rolled back to the initial, and it will going to start by from the initial only. And database rollback, so that is restore the RDS instance from the snapshot created before deployment. So in case of disaster things, so we will going to restore the same infrastructure along with the data with the help of snapshot. And the same for API also, that is the rollback procedure will will going to regularly ensure the effectiveness during the disaster recovery things, and maintaining the secondary cluster as well as instance in different region as the failure mechanism. So assume that if we are if we have deployed our application or the whole infrastructure in one region, US North region, so the complete region got down due to some natural calamities, or it could be of maintenance thing. So on that case, what it is very much recommended to have the same infrastructure to be replicated in another region, so that if one region goes down, so automatically we can release the another region. So that is, we can make available of another region. So whatever the data as well as what are the functionality we do have in that region, initial region, so the same thing will be replicated in that region also simultaneously. So here we do have the integration things, that is the implementation part. So how we going to integrate from the scratch thing. So provisioning an RDS instance. So it is very much important to store any data related things. So we need to have the database. So since we will be going with AWS ecosystem, here we will be going with RDS. Inside that engine, we will be going to use MySQL and note down the endpoint and the username and password of the database. So to establish the communication with the database, these three keywords or the values are very much important. So without endpoint, we cannot able to access the database. And if the database is secured, so we need to provide the username as well as the password for that schema. And so we cannot directly go and either we can access the database from any of the consoles by using either EC2 instance or like things. So if you want to access your database, we can either go with MySQL Workbench. It's a community service provided by the MySQL. So where we can go and link with the help of endpoint as well as username password. So we can able to view the complete database visually. Fine. So that is the, with the help of UI, we can able to manage the database. For that, here we will be going with MySQL Workbench, where we're going to access this RDS MySQL instance with the help of endpoint, username, password to connect to the database. And thereon we'll go and create the necessary tables. Okay. And if we required any initial data to be stored, we'll be going and storing that. And test the database integration. So before we go and deploying the application, so we need to test the data locally. That is, our database need to be tested locally. So whether the data is going and storing in the database properly, whether we can able to fetch the data and the data are getting updated in the database. All these things to be considered before we go and deploy the things. And once the database have been set up completely, so the next step is to pull the code from the repository. That is, set up the GitHub repository. That is, we need to create the new repository in the GitHub account, and naming convention should be followed with respect to your project. So verify the Spring Boot project structure in the repository. So there will be some formatting thing. So we need to verify that, like XML file and application property file. So these are the basic files needs to be present in the GitHub repository. So where they play a major role while processing the pipeline. So ensure that source directory contains the POM XML as well as Docker files. So the POM XML file having the all dependencies as well as information related to the application. So what are the technology, what are the packages we have been used, and how the API calls, everything is happening. So that is in the POM.xml. That is project object model file, and the Docker file. So we required the Docker file to build the Docker image, right? And for that, we need to have the Docker file in the GitHub repository itself. So the artifacts post successful run of Jenkins pipeline. So artifacts or the things will be stored in the GitHub repository only. Next is we need to add the Jenkins credentials for GitHub. So in Jenkins, that is to access the GitHub, we need to add the GitHub credentials to inside the Jenkins. Okay, so we need to just log into the Jenkins master and go inside the manage Jenkins followed by the credentials, and in this path we need to store the GitHub credentials. So once the credential has been stored, and we need to provide the proper naming for accessing the credentials in the pipeline. And after adding the username as well as the personal access token of the GitHub, so we'll go and integrate the repository with the Jenkins. That is, here we'll go and write the script, pipeline script. Okay, so create the new job, either of the type, either freestyle or the pipeline. So under source code management, select the Git and provide the repository URL followed by the credential. So once the initial thing have been provided to the Jenkins pipeline, next is we need to install the plugin. So before we go and run the build, so we need to configure the Maven in the Jenkins. So since we are using the Spring Boot application, so we will be going with the Maven package. For that, that is Jenkins pipeline to build the application. So install and configure Maven. So we need to install the Maven plugin inside the manage Jenkins. If you go inside the manage Jenkins, so there will be having the available packages like these. So there we need to search for Maven and we need to install, and also we need to set the path in the root machine or the where Jenkins is running. In that server we need to specify the path. So whatever the artifacts, all the things that even will go and store in the server also. So we need to write the script. I will show you later. Next is a pipeline breakdown. So in pipeline we will be having the multiple stages. So what are the stages we'll go and come across if any new commits have been happened to the GitHub repository. Okay, so assume that the developer has committed new changes to their repository. So these are the breakdowns it will going to happen, or these are the stages will going to happen once new commit have been changed. That is, it will going to pull the latest code from the GitHub, and once the pull is successful, it will going to build with Maven. That is, uses Maven clean and package the application. So it will going to, that is mvn clean package is the command to build the Spring Boot applications or the Maven based application file. So where it will going to generate the .jar file. So once after the jar file or the build got successful, so if we are able to see the build successful, obviously the jar file will be created. Okay, so once the jar file have been created, again we need to, our next job is to build the Docker image. So why it is required to build the Docker image? So if we are going and deploying our jar file in a direct application means, so it will going to consume a lot of space, and we need to install all the time all the dependencies, and we need to expose the port number and all the things. So if we are going to create the Docker file means, so we can have that Docker file and we need to only run that container. That is more than enough to access our application. So this is much easier while comparing to the older deployment strategy. So that is why nowadays the people are moving into the Docker containerization. So once if we have the Docker containerized image application means, so we can also share that thing to the other teams also, whoever is involved in the stakeholder. So they can able to easily test that application and they can verify the thing. So in older times, we need to deploy each application. That is, we need to install the Java and we need to have the dependencies and we need to expose the port number, and thereon we need to run the application. So it is going to quite long process of installing all the requirements and maintaining the server and all the things. So once we are going with the Docker container things, so everything is being taken care by the Docker image. Only thing we need to provide the proper details before the Docker image creation. Okay. So once the Docker image has been created, so we can directly push that image to the Docker Hub for archival fan or the maintaining the version thing. Also for that, for all those things we can maintain the Docker Hub. So it is quite similar to the GitHub repository only. So where we going to store our things. Next is you can deploy it on the Elastic Container Service also, or you can directly go and deploy it in the server also by installing the Docker. So for that, we will have to priorly return the Docker file. So on this, by referring to this Docker file only, it will going to build the Docker image. Okay. So next is deploy the application on ECS. So here I have just mentioned the ECS thing. So in implementation, I have gone with it is Docker deployment only. So I haven't used the ECS. Directly inside the EC2, I have deployed the application in the Docker only. So next, the API calls. There I will be going to use the public IP of my EC2 instance. From there, I am going to access the application. Yes. So the architectural diagram for complete automation from.
Now that's all you have in the PPT.
Yes, sir. This is just documentation. These are the things I have included.
So add one more slide for question and answer.
Okay.
Question and answer section. Okay. And what we are going to do is we'll continue this session. The next session, review the code in detail, and I will see the demo for each and every of these topics.
Okay, sir.
Okay. I'll give you a slot for that.
Okay.
And once this exercise is done with the complete demo, then I will get you ready for all the questions for all of these services.
Okay, sir.
Okay. So can you do one thing? You have list down all the services, no, in Excel file.
Yes, sir.
All the services from AWS which you have now prepared.
What?
So that Excel file you put it in the Google Drive in your folder. Do you have it already or?